Hi guys, it has been exactly a year since I posted a video with the first version of this solar battery management system. Most of you that watched that video made comments about the low current handling capability of the first version, so I took that into account and basically doubled both the charging and discharging capabilities from 20 and 40 amps charging and discharging on the first version to 40 amps charging and 80 amps discharging on this new version. It took so long because I took a break to build my off-grid house, as some of you may already know. And this product in itself took just over 6 months to develop up to this point. That include the hardware and the software. And there will probably be a few more months to make it final hardware version and finalize the software and do all the necessary testing before I will produce this unit. This brings me to my next point, which is that I will run a Kickstarter campaign for this product. This will happen very soon, in the next few weeks probably. Even if this product was developed for my own needs, especially the electrical system on my off-grid house, I will also have some other project in mind for it. It will seem like a big chunk of my life dedicated to this product that I only use, so in order for this not to be the case, I'm interested in building a small run of this BMS, at least 50 pieces. 50 pieces will be my target for a Kickstarter, and I hope to get more people than that, but I'm not sure since I don't have a large audience on YouTube or any other social networking website. If you have any ideas on how to promote this product, I will be very interested, so please share that with me. I know many people will be interested in this product. The problem will be how to get to them. This solar battery management system, as I call it, or SBMS4080 for short, can be used in a large number of applications, starting of course with off-grid solar installation, but also many other projects that requires more than 3 up to 8 series connected rechargeable lithium cells, or any type of ultracapacitor or supercapacitor, of course. Some other examples may be electric bicycle or scooter, or anything with a motor up to 2 kilowatt, or even some small low speed 3 or 4 wheels vehicles, maybe solar vehicles or something like that. Solar battery packs can be another. The remote control cars and quadcopters. People can use this to charge their battery banks or ultracapacitors with a small solar panel on site. But enough with this. I will start now with a short hardware presentation, and then I will show you the software, actually the user interface part. The device is composed of 3 PCBs. There is the main one in the middle that you can see here, and I will go in more details about this. Then there is a bottom one that is on an aluminum substrate for the power components, like the input and output MOSFETs, the current shunts, the main power connector, and a few other parts, related parts in here. And there is also the front PCB panel that mainly consists of the capacitive buttons and board interconnect connector, nothing else. Okay, back to the main board here. This is the connector that connects with the power board. Then I have the main IC in here. This does most of the analog stuff, like measuring cells voltages and measuring current, and taking care of overcurrent protection, and controlling the MOSFETs, and most of the things related to batteries are done inside this IC. And then I have a bunch of passives here that are the filters for the cell input voltage measurements. And then some resistor arrays here, and then more resistors. And these are the MOSFETs for the cell balancing. These are the N-type, and I just need to get here the P-type MOSFET that I don't have yet, but I will need to test also. This part is not yet tested, but it should work. There is no reason not to work. And this strange deep package in here, the only deep part in here, this is actually a resistor array. Probably not what you will have guessed, but yeah, these are 8 power resistors in here, encapsulated in this deep package, and this will be used to balance the cells. So I will be dumping power in this to discharge the highest cells, and in order to balance the cells. Okay, then next, these are the opto-isolator that I use. So I can have serial communication outside of this for data logging, or I don't know, any other purposes, but mainly for data logging. I have some other ideas for this if they are not used for data logging, but I will tell you about this later. And then here is the power IC, I mean the DC-DC converter. This is a really nice unit. It's high efficiency and very low bias current. I think it's 80 microamps if I'm not mistaken. And so this is the reason I could have such a low power consumption on this unit. And then I have the microcontroller, like I already mentioned, I think. This is a 32-bit ARM Cortex M0 microcontroller. This is new. I exchanged it from the last version because that one didn't had the external pins for the clock oscillator, and I needed a 32 kilohertz external clock oscillator in order to have a more precise time base for the data logging. So I tried to implement a watch with the internal low speed oscillator, but that one was really bad precision, and it was really not good enough. It will lose minutes in one day or something like that. It was not good for having a good watch for data logging. And this is a 32 kilohertz clock oscillator from Citizen, I think. So this is one of the additional components from the last version, and also the microcontroller. It's larger now, but there is enough space on this board, no problem with that, since this is almost double the last version. And this is the SD card slot that I'm not sure if I will be using or not. It will depend on how much space I will have left after I finalize everything in software, and if I still have enough space to implement or not a FAT file system in order to have this working on a PC. If not, maybe, and if I sell more than 200 of this and I implement this part, then and I don't have enough space for the FAT file system, maybe I will do just a raw data logging and then downloading this via serial port, but it remains to be seen. Anyway, I think this is the hardware part, and on this other side is just a LCD and another connector that connects to the front panel for the touch buttons. So this is it, nothing else. So let me show you the menu system. As you can see, to navigate through the menu, you have 3 buttons up here. And this was supposed to be a scroll wheel, but there will be another 3 buttons. There will be a different type of arrangement. There will be 2 rows of 3 buttons, and these 2 are up and down keys, and this one is load on off, and then the other ones you already see, menu, back, and OK button. And the reason that I didn't use the scroll wheel, this one was supposed to be a scroll wheel, was because it was not very sensitive, for one, and secondly, maybe even more important, it took a lot of space in program memory, about 6K, and I'm starting to get a bit crowded in there. The program is quite a bit larger than I expected, and I still have to implement a lot of modules, so I took the decision to use only capacitive buttons and no capacitive scroll wheel. And these 2 buttons will be up and down key. It will be a different kind of arrangement in the end. It will be 2 rows of 3 keys, and it will be an up and down key, a load on off key, menu, back, and OK key. These are already here. Okay, so let's get inside the first item. This is monitoring. As you can see, I have the voltage for each cell on all 8 cells with 1 millivolt resolution. I have the total battery voltage and the battery current, in this case, displayed in a single screen. And I have here 5 screens. This is screen 1 out of 5, but I can have more or less. It will depend. It's not exactly done here, but to move to the next one, you just push the down or up key, and as you can see, here is also the voltage on each of the 8 cells, but in this case they are represented as analog values with these bar graphs, and this is still the total battery voltage, 12.21 volt, and I can have the current on the other side, but this is just a demonstration. I'm not sure how I'll implement this in the end. I can get suggestion from you if you have any ideas of how I could represent best the data that I have, then please leave the suggestion in the comments, and I'll be sure to read them. Okay, then I have this screen, which is just the voltage and the current on the battery, the total voltage and the current. And also there I have here some longer bar graphs to represent this value in an analog fashion. Maybe it's easier to interpret just glazing at the screen. And yeah, the rest of the screens are empty. It's just I need to think about how I will arrange this data, but as you can see, the readings are working, and I actually have quite good precision and resolution. I will show you later how precise these measurements are, comparing them with the bench multimeter. Okay. Next menu is also almost done. This is a parameter set, or as you can see, there are 34 parameters in here. You need to scroll down to see them all, and you can modify each of these one and then save them. I will show you how you will save them, but the saving part is not implemented here. It's somewhere outside in a different menu, but it will be implemented here. I just don't know exactly how to do it right now. Anyway, as you can see, there is a cell type. This will be, I will have here probably up to 16 predefined thresholds for different type of batteries and ultracapacitors, because this will work with both lithium cells, any type of lithium cells from 3 to 8 cells, and with ultracapacitors, preferably more of them, like 7 or 8 in series, because ultracapacitors have lower voltage per cell, and this device can work down to about 7 or 8 volts. It will not go lower than that. So if you want to work with ultracapacitor, it's a good idea to have them at least 6, or better yet 8 of them in series, and as many as you want in parallel. And then I have the number of cells, in this case 8. This is the current setting, but you can set anything from 3. This is the minimum setting, 3 cells, and the maximum is 8 for this. And then I didn't wrote anything here yet. It will be the capacity in amp hour for batteries, so that can I accurately calculate the remaining capacity in a battery. I need to know what is the capacity of your battery bank. And in case you use ultracapacitor, it will be the capacity in farads. So I will need to have here two type of units for this menu. And this is over voltage, and how much time to wait. This 1 second. How much time to wait after it found that this over voltage was exceeded, this threshold was exceeded. And then this is over voltage recovery, and under voltage delay, how much time again it will wait after the under voltage is triggered, and a lot of other thresholds related to voltage and currents, short circuit current and delays for that. And you also have, if you noticed, you have a scrolling help on each item. So if you wait long enough, you can read help explaining what this or each parameter is about. So I think that will be helpful. You will not need a written manual if you have this type of help. At least this is my idea. So let me know what you think about this. And this is the balance, to do balancing of the cells at discharging or at charging, or both. You can decide that. And what are the limits? And this is the time before it enters different stages of low power. If there is no current through battery for longer than these timings here, it will enter low power modes to save even more energy, even though this device is quite low energy to begin with. So yeah, I will not go through each of these parameters because it will take too long. There are 34. If I need to explain everyone here in this video, I will get this video way too long, and I don't want to do that. So the next one, actually let's skip this one and go to diagnostic. This is a menu that I'm currently using, but it will still be present here even though in a much more user-friendly way than it is now. But after you've seen here all these parameters, you can change them by pushing OK, and with up down key you can set what value you want, and then to save it just push OK key and it's saved. But it's saved only here and it's not transferred to the main IC, so this will not take effect until you wrote this or saved this data to the main IC. And in order to do that, I will need to have a menu inside that parameter set submenu, but for now I'm using this diagnostic menu to check and see what is inside the EEPROM. It's not a ROM like I wrote here, but inside the EEPROM of the main IC and what I modified there, and I want just to make sure that it's at the correct address and everything. It's just things are not finished yet, but everything works fine. I don't need this anymore, but I need it for writing the data to the main IC, and to do that I just push OK in this case here, and all the about 87 location of EEPROM will be written with appropriate thresholds and whatever is there. And now it's written, everything is okay. And what else? Device set. So in here also a lot of things are not finalized yet, but I have the time and date, the clock is working. As you can see, it's not a current time, it's just a random thing that I have here. But again, you can set it in the same way, push OK to select, and then set the hour, and now you see it's 17 hour and 30 something minutes. And you can set the date and the time here. There's nothing exciting here, but I need this for in case I use data logging. I need a timestamp, so that's why I need a precise clock. And then I have here the LCD brightness. I don't think you'll see anything. It's actually on full brightness right now. I mean, the backlight, it's on full. There are two levels, low, high, and off. But I'm sure you will not notice anything because I have a lot of light here. I don't think you'll notice anything, but let's make it off to see. Yeah, maybe you notice something. I don't know. I'm not sure. I'm looking at camera LCD, but I'm not sure. Anyway, let's leave it on, full on. This is low level and this is high. And then it will be a timer to switch off the backlight in how many minutes you want. If it's left to 0, it will be always on at a setting that you done before. And maybe I will implement a contrast. I'm not sure about that. You can set the contrast of this LCD, but I think if I set the maximum contrast, it will be okay. But I will see if this will be implemented or not. And device set, I have a lot of ideas for this part. but I will not go into details about them right now. What else? Micro SD data logging. I will implement this if I will be able to get at least 200 people interested in this device. Otherwise, it will take me too much time, and I don't want to spend so much time if not many people are interested in this device. And then there is the serial communication port that it's fully optically insulated. And again, if over 100 of this will be sold, then I will implement data logging using a serial port, and I will have a cable that will convert serial to USB, and you will be able to do data logging using a computer or a tablet or phone or anything that has a terminal or something like that, and could save the data that came out of here. And probably will be even more complex than that. And in case that this serial port is not used for data logging, it can probably be used for some other stuff, like there will be an input and output I/O fully insulated, optically insulated, so you can use them for I don't know, letting you know that the battery is fully charged, or that a certain threshold, battery threshold was met, like I don't know, voltage or current threshold, and then this output pin will be on or off, or something like that, and you can use this information to do, I don't know, something else. There could be many things that can be done with this, in case you don't use data logging at that time. You can use this for something else. Okay, and then I think this was the last thing here in here, and yeah, this is the about thing. It's just it's nothing here, it's just software and hardware version and model number, SBMS4080. This is from the current handling capabilities, 40 amps for charging and 80 amps for discharging. So it can use up to 1000 watt of solar charging or different type of charging that you want to use, and up to 80 amps, that's 2000 watt of maximum, depending on your battery configuration. But if you have 8 cells and there are some sort of lithium cells, then that's just over 2000 watt of power during discharging. Okay, this is all I think about the menu system. If you have any ideas of how to improve this menu system, please let me know. Or if you want something implemented, you should also let me know before I finalize this software and I don't have any space left to implement anything else. Okay, so this is the test setup. I have here 8 UltraCapacitors. They are 220 farads, 2.3 volt. These are connected in series to make up a battery of UltraCapacitors. I don't use batteries because it's easier for me during tests to use UltraCapacitors. They charge and discharge much faster, so I could check the thresholds. And then I have this CCCV, constant current, constant voltage power supply that I will use for charging. So it will simulate a solar panel or a power supply. And then I have another CCCV power supply that will be used as a load together with an LED. So this will be used like LED driver, something like that. I don't have anything else at the moment. And then I will also be using this bench multimeter to show you how accurate the readings from Solar BMS are. Okay, now the load is connected. You can see this wire. All ground points are met at the battery for charger and load. So ground, the negative from the battery is common for load and for charger. So only the positive terminals will be connected here. The first 4 here are for the load, and the next 4 are for battery, and the first 2 are for the charger or solar panel. If each of these terminals can support up to 20 or I think 25 amps, so there is no problem. Okay, so it's charging now, and you'll see when it gets to 2.2 or 2.19 volt. I think that was the last setting that I done in the parameter setting. Check the cell 7, it seems that's the highest one, and now it got there and it powered off. So the charging is done for these ultracapacitors. And now if I connect the load, I should first maybe leave it on. It will make some sparks because it will charge the capacitors, but it's fine. And when it will get down to 1.95, I think, the highest voltage, it will start charging again, because that's over voltage recovery voltage threshold that you've seen in the menu. And then when it gets back to 2.19 or 2.2, I don't remember, then it will shut off. And yeah, it's 2.2 because we modified to 2.19, but we didn't reset the BMS since then, so it didn't took into account the new parameters. In order to, if you change the battery, you should reconnect the cables. I mean, it's obvious you cannot change the battery without changing the cables, but okay, now I will measure the voltages on the battery. On the entire battery I have 14.95, so exactly the same as on the BMS. And then let's measure cell 1. It's 1.40 on the BMS, 1.838 on the multimeter, so really close, like a 2-digit. Cell 2, 1920 on the BMS, or 1918, something like that, so around 3 digits again. 846 and 848, I think, on the BMS. I cannot see the screen very well from this distance, and the camera is in the way, but you can see the idea. So it's this is cell 4, so they are very close. And now I should measure the current. Okay, let's measure the discharging current first. So it's 0.68, 0.7 on the BMS. That's accurate enough. I mean, I don't have better resolution, and I cannot get better resolution for the BMS than 100 milliamps, but that should be good enough. And now for charging, it's 1.74, so it measures 1.8, I think. Yes. So again, this is good enough, and as you can see, there is a plus sign on the BMS showing the current is going into the battery, and minus if it's going out of the battery. I think that makes sense. If you think that it should be reversed or something, let me know, but I think plus is for charging and minus for discharging the batteries. Sorry for the low image quality, camera is not that great in low light condition. But as you can see here, with full brightness on the backlight, I get just under 4 milliamps of power consumption. And then with backlight at low level, it's about 2.8, 2.9 milliamps. And just under 1.6 milliamps with the backlight off. As you can see, it's not important in which mode you are. So even if you are in monitoring, it will still use the same amount of power. And at 4 milliamps and 15.9 volt, that's about 62 milliwatt, and this will be the maximum no matter the battery voltage, because this uses a DC-DC converter, so the power consumption will stay the same and the current will drop with the increase in battery voltage. So you will never exceed 62 milliwatt on high with the backlight on high, and as low as 25 or so milliwatt with the backlight off.